So I'm going to run through at a high level how to set up a Spotify client, Spotify API client, and then I'm going to go through more detail on the two types of graphs we're using here, tree maps and rooted trees. So before I start, I want to point out this repository from Coding for Entrepreneurs. This is where I learned how to set up a Spotify API client, and I recommend going there when you're through here so you can learn in more detail. First things first, you're going to want to know you need to set up a client ID and a client secret. These are some alphanumeric variables that will let you actually access the API. So there's a link in the GitHub repository for you to go find that and set your own up. The main thing we use here to call and receive data from Spotify, we set up as a class called Spotify API. A couple things I want to point out. Get client credentials. This method is basically how we send our credentials, the client ID and the client secret, and then return an authorized and approved sign-off from Spotify so that we can go get that data. That actual authorization happens here in this method, perform auth, where it takes this information we're sending and it returns back true or false whether our approval has been granted and whether or not our token is still live or if it's expired. So moving along past some of this more minutia on the API, I want to get to this key method here, getResource. This is kind of our parent method that lets us call some other child methods such as getAlbum and getArtist. GetResource basically takes an endpoint which accepts a version, a resource type, and a lookup ID, and goes to get the data we're looking for. So when I say resource type, what I mean by that is albums or artists. Tracks is also another one. And it takes these things and it goes to Spotify and says, hey, here's what I'm looking for, the name of some artist, the name of some album, and it says, great, I found it, and it returns a JSON object, and that contains all of our data, so the information about that artist or album. The getAlbum and the getArtist method are super basic. They just designate the resource type that you're looking for and then run it through the getResources method. The search method is similar. It has a slightly different endpoint, but basically what it does is takes the search type and sends that through to get possible results from Spotify. So this is the same as when you actually do a normal search on your Spotify on the phone app or on the web app or wherever. The last one I'll point out is this getRelatedArtists method. This takes a slightly different endpoint in that it's looking specifically for an artist based on their ID, and it's giving you the related artist. So, you're looking for Led Zeppelin, and it'll give you, the Rolling Stones are a similar band. Now, having set up this whole class, we want to actually set up the client. And that's what we're doing here. Calling our class, giving it our ID, giving it our secret, and calling that variable Spotify. Then we can use that package and call the methods from within it. So we pass it here the query string when the levy breaks, and that's hopefully going to give us back tracks that match this query string. So artists that have songs that have the track containing when the levy breaks. Having performed this query right here, we are returned the search result object as a JSON dictionary. And we're going to loop through that dictionary and append items to our own new dictionary called ArtistDict that's a little bit more sorted and easy to read. So first things first, we go get the name of the artist matching and the ID of the artist matching from the results. Then we actually use our getArtist method to go get the data for that particular artist, specifically targeting their genre that they're categorized under, the URL to get to their website, and the number of followers. So for example, I'm going to show you here, ArtistDict is the name of our storage dict. If I do .keys, it's going to show me all of the artists that were returned. And you can see here, Led Zeppelin was returned, Perfect Circle, Whiskey Myers, and more. If I use Led Zeppelin as my example, and I call on that particular key, you can see that we have their ID here. This is going to be consistent across all Spotify users, right? So you can always use the same ID for Led Zeppelin. The website to actually go to their page. So we can test this here by actually launching it and seeing if it takes us to Led Zeppelin's profile page on the Spotify web application. We'll give it a second to load here. And there it is. We have Led Zeppelin's page. You can see their songs, etc. Closing out of that, some other information we get. The number of followers. This is key. We're going to use this for our graphs. Their bands. So we're going to look at, not their bands, their genres. And then we actually do a primary genre assignment below. So that's our dict. The next step we're going to do is look at the unique genres, right? So we want to look at across all these artists that we were just returned, what genres were common across all of those artists. This just creates a list here where we have those unique genres and sort them alphabetically. The first 5 of which are acoustic blues, album rock, etc. Next, we want to assign a primary genre to each artist. We do that here in a really basic way, just looking for the first in the alphabetical list of that artist's genres. There's absolutely more sophisticated ways to do this. Basic example for our purposes here. We put all this information into a data frame from pandas that has 3 pieces of information: the artist name, their primary genre, and their number of followers. We use the drop NA method here to remove nulls, so any artist that didn't have a primary genre or that didn't have any followers. And we then use the sort values method to make sure that the bands with the most followers are at the top of our data frame, just for cleanliness. Next, we're going to jump down here to this first squarify plot. So this is what we call a tree map. And what it's showing us is the relative size of the bands in our result that are sorted by followers. So you can see here Led Zeppelin is way bigger than Great White or Perfect Circle. It's because they have the many more followers. And we can jump up here and look at that proof here. Scrolling a little bit, we can also look at our data in terms of size of followers per genre. So album rock is much larger than modern southern rock, than alternative metal, etc. And that again has to do with the genres that are associated with the bands that were returned by our result. Now, these are interesting, but not that useful. What if we look at it in terms of both genre and artist? I'm going to jump down here to this slightly different formatted tree map. This is using Plotly Express, while the ones above were using Squarify. Different packages, same type of graph. This one's a little cleaner, it gives a little more information. So you can see that this tree map gives us by genre. So album rock contains 3 bands: Led Zeppelin, Great White, Sammy Hagar. Then the next genre, alternative metal, contains just 1 band, A Perfect Circle, etc. So it's a little bit more configured, gives you more information. As you would expect, you want to have a good amount of information here, but not too much. You don't want to overwhelm the viewer with too many pieces of information, because then it won't be readable. You want people to be able to look at your exhibit and quickly understand what you're trying to communicate. So that's our example of a tree map and the one we're going to use. Now, the other piece of information we want to know is, okay, so we know Led Zeppelin's in here, we know that Silversun pickups are in here. What are artists related to those artists? What types of bands are writing songs or covering songs like When the Levee Breaks? So we pick one of them, for example, Led Zeppelin, as our target artist, and then we use our Get Related Artist method from Spotify to learn more information about them, who are related artists. We again store this in a dict that shows you not only the names of the related artists, but also some more information about them, such as their genre and their follower counts. You can see for Led Zeppelin some pretty expected names here: Robert Plant, Jimi Hendrix, The Doors, but this isn't super well sorted. We're going to address that a little bit further below in our first rooted tree map. Before we get to that, we're going to transform some of this information so that it's more easily assigned to the graph that we're going to create. So the first things we're doing here is we're creating a data frame from the dict that we just stored, right? So this dictionary we send to this data frame. We sort the values by followers again, so those with the most followers are at the top. And then we slice it to the first 10. So we only want to look at 10 artists here, even though our resulted number of artists here is closer to 20. It's just we want to keep our graph concise, so we sort to the 10 here, filter I should say. Then we actually set up several numpy arrays, because those are what are most easily passed to the graphing module that we're going to look at below. And we do some transformations here to make sure we can construct the graph. We're actually technically setting up a scatter plot And so while what we're going to look at is a rooted tree, we said it also want to scatter because that also gives us a sense of direction in addition to relationships, and I'll explain that a little further. But all this is doing is setting up two new lists, x-axis locks for the lines, so locations, and y-axis, I should say, and x-axis. This gives us the way we plot out our scatter. And then again, another couple sets of lists for setting up the lines of the scatter, and you'll see that here. Now, the Go module is the graph objects module, and it's how we set up our figure that houses our graph. We update the layout, giving the graph a name, giving it some more specifications like taking away the tick labels, giving the y-axis a title, things like that here. We specify the colors of our fonts, and we actually add the scatter to the graph. Now what results is this graph here that is our rooted tree. You can see Led Zeppelin is the parent, and these bands are the children. So Rolling Stones, The Doors, Black Sabbath, these are all related artists from Led Zeppelin. So if we were to look at Led Zeppelin's page, you'll see all these artists, and you can see not only have we plotted them on the as children to the parent, we've actually also put it on a scatter so that you can see the number of followers. So Led Zeppelin has over 10 million followers. You can see it above this line here. Rolling Stones have about 9.5 million followers. Doors about 5.5, right? So this is actually a two-part graph, both showing relationship and showing frequency. And by that I mean the count of the followers. So that's it, folks. We've got our rooted tree graph. Up above we've got our tree map graph. They actually are similar in that they show relationship, they show relative sizing. They're not the most common graphs that you're going to see. You're more likely to see pies, you're more likely to see histograms, but don't overlook these. They can be really useful and show that you have a creative way to showcase your data. So thank you for watching, and reach out to me if you have any ideas for anything you want me to explore.